Every decade, a new generation of wireless technology redefines our world. But the transition to 6G is more than just another step in speed. In the 6G era, the boundaries of possibility are being rewritten by intelligent frameworks. It is a fundamental shift in how we perceive communication itself. We are moving from the era of connecting devices to the era of connecting intelligence. For decades, we have focused on the technical level, how to transmit bits accurately across a noisy channel. This was the Shannon limit. In 6G, we look higher. We are entering the realm of semantic communication, where the goal isn't just to send data, but to pass meaning. By unlocking the potential of large AI models, we can design systems that are not just faster, but fundamentally smarter. Imagine a system that doesn't just hear the words, but understands the intent behind them. This is meaning passing. By extracting the essence of information at the source, we can communicate even when the connection is weak or the environment is noisy. This paradigm shift allows for incredible efficiency, reducing the need for massive data transfers while maintaining perfect clarity of intent. But how does a machine truly understand meaning? The secret lies in a concept called the knowledge base. For semantic communication to work, both the sender and the receiver must share a world model, a background understanding of the context. These knowledge bases are not static. They are living systems that learn from their environment, constantly updating their understanding of the world. When the source and destination have slightly different knowledge, the system works to bridge the gap, minimizing semantic errors before they occur. Enter the power of large language models. In 6G, these models aren't just for chat. They are the engines of the network itself. To manage the complexity of the future, we rely on multi-agent systems, armies of specialized AI agents working in perfect harmony. Frameworks like COM-LLM use these agents to retrieve data, plan solutions, and reflect on their own performance. First, data retrieval agents mine the knowledge base, summarizing vast amounts of information into precisely what is needed for the task. Then, collaborative planning agents break down complex problems into manageable subtasks, generating feasible paths forward. Finally, evaluation and reflection agents assess the results, refining the system's strategy through continuous self-learning. A practical example is the design of semantic communication models themselves, where these agents collaborate to build ultra-efficient systems. This isn't just happening in a central server. It's happening at the edge, in every device, in every corner of the network. One of the most exciting frontiers of 6G is the rise of the UAV swarm, fleets of autonomous aerial systems. These swarms require unified perception across text, image, and video modalities to navigate and coordinate in real time. Multimodal large language models enable these drones to reason and communicate in natural language, even in the most challenging missions. Through collaborative inference, small on-device models handle quick decisions, while complex reasoning is offloaded to the cloud. In disaster response, like forest firefighting, these swarms can autonomously identify threats and coordinate suppression with zero human intervention. To make all this possible, we need a new unit of communication. We need the token. Token Communications, or TOCCOM, treats tokens as the basic processing unit for text, images, and audio-video signals. Using transformer architectures, the network can leverage cross-modal context to predict and fill in missing information. If a packet is lost, the system doesn't wait for retransmission. It uses context to predict the missing piece, keeping the flow seamless. This allows for ultra-low bitrate communication, achieving 24% bandwidth improvement with no loss in semantic quality. By integrating cross-modal context, an image of a dog can help the system more accurately reconstruct the sound of its bark. TOCCOM also enables semantic multiple access, where multiple users can share the same channel, separated by their unique semantic context. The result is a network that is remarkably robust, even in the most adverse channel conditions. Of course, these advanced systems face challenges. LLMs are resource-intensive, requiring efficient hardware and edge cloud collaboration. Privacy and security are paramount. Tokenized representations carry semantic payloads that must be protected from inference attacks. As we look toward the 6G era, we see a world of holographic teleportation, the Internet of Senses, and immersive communication. 6G is not just about faster internet. It is about an intelligent fabric that weaves through every aspect of our lives. We are building a future where communication is intuitive, seamless, and powered by the very meaning of the information we share. The journey from bits to tokens, from data to intelligence is just beginning. Welcome to the future of connection.